A lathe is a machine which is used to perform various operations such as cutting, knurling, turning, facing, etc. with tools that are applied to a piece to create an object which has symmetry about an axis of rotation. Now starting with the main parts of lathe, from the bottom, these are the base mountings. These two are the base mountings. This is the column housing, which contains motor drive mounted at the bottom. This is a motor drive. Through the belt, the rotational drive comes to the upper part of the machine known as headstock. This is the headstock. This headstock contains all the gearing mechanism and the spindle of the machine. By operating the button, the spindle rotates and with it a work holding device, that is a three-jaw chuck, also rotates. Workpiece is mounted and gripped firmly with a three-jaw chuck. Now, after the headstock, there is a parallel long lane known as lathe bed. On the top of lathe bed, there are two guideways. These are the two guideways. The part which moves on the lathe bed is known as carriage or saddle. This is the carriage. It can move forward or backward by manual hand feeding also. Likewise, it's moving forward or backward by manual hand feeding. The part can also be automated as shown by operating the button and engaging the lever. In this way, the carriage can be moved by automation. Again, by releasing the nut, the manual hand feeding could be again resumed. This is how the nut is released. So the manual hand feeding is resumed. The front portion of the carriage, which contain all the mechanism for manual hand feeding and automated feeding, is known as apron. This is the apron. Over the carriage, there is a compound slide for crossways movement of the tool. Now, over the carriage, there is a compound slide. This is a compound slide. This compound slide provides a provision by which we can tilt the tool at any position, hence a required angle for taper turning can be set. Over this compound slide, there is a tool post. Tool post accommodates cutting tool. This is a single point cutting tool. This is locked with the help of nut and bolt. This is how the tool is locked in a tool post. Nut and bolt mechanism helps in locking. After the tool post, there comes another part of the lathe on the lathe bed, which is called as tailstock. This is tailstock. It can move forward or backward and could be locked with the help of spanner. This is how it can be locked. This is used for supporting a lengthy workpiece. There are two parts of the tailstock. Firstly, there is a base which you can position to a 0, 0 reference, or you can offset it to a certain amount. This offset is useful in a small tapering of the workpiece. Tailstock has got the top portion which has a slider known as a quill. This is a quill. This quill accommodates the dead center for supporting lengthy workpieces. This is a dead center. Other work holding devices can also be mounted like a drill chuck. This is a drill chuck. This drill chuck can accommodate your drill as well as your reamer. This is a drill bit which will be held firmly in a drill chuck. Now another work holding device is a 3-jaw chuck, also known as self-centering chuck. This is mounted on a spindle. This 3-jaw chuck is used for holding of a cylindrical workpiece or hexagonal workpiece or any other symmetrical workpiece. The jaws are positioned simultaneously, that is, the opening and closing is a simultaneous action. As you can see, by loosening the nut, the jaws, all three jaws are opened simultaneously. Hence, because of the simultaneous movement of all three jaws, this is referred as a self-centering chuck. Now this is how the jaws are closed simultaneously and the job is centered. Now this is a 4-jaw chuck. It is an individual chuck. It is used for holding of an irregular and odd shaped workpiece. So we can position the workpiece in center by individual movement of 4 jaws. As you can see, these 4 jaws can be individually aligned so as to center a odd shaped workpiece. This 4-jaw chuck can be mounted on a spindle. To give a more clearer view, this is how the individual movement of all the 4 jaws takes place. As you can see, the upper jaws can be slided down without affecting the lower jaws. Similarly, the other jaws can be moved individually. Another work holding device is a driving plate. This is a driving plate. As you can see, it contains a slot and a pin. This is a pin. At the center of the driving plate, there is a live center. The live center rotates and gives a positive drive to the workpiece. Hence, it is called a live center. Another work holding device is a lathe dog. This is a lathe dog. It has got the tail, the hole and the bolt. These are of various diameters according to the sizes of the workpiece. Now we'll see that how a lathe dog and a driving plate can be used to hold a workpiece. By fixing a workpiece between the live and dead center as shown, we bring the live dead center towards the workpiece and lock it with the help of spanner. This is how the locking is done. Now, after firmly fixing the workpiece, we see that the job starts rotating. Now, as we can see that the workpiece is getting a positive drive with the help of and lathe dog and drive plate. The lathe dog is supported by the pin of drive plate, which gives it a positive drive. Another kind of work holding device is a collet. This is a collet. The collet is used when we don't want to disturb the outer finishing of the workpiece during machining process. Suppose this is a workpiece and we don't want to disturb or damage the outer finishing. Then we can fix this workpiece in a collet. This is how the workpiece is fixed in a hole. This collet can then be applied to the spindle of the lathe and the workpiece can be held firmly. Another kind of work holding device is the faceplate. As you can see, the faceplate can also be mounted on the headstock with the help of a spindle through the hole given in the center of the faceplate. As it's visible, the faceplate consists of various slots on the plate. Any odd-shaped workpiece can be mounted using nut and bolt mechanism inside the slots given. As you can see, the various slots are given. Now we'll show how any odd-shaped workpiece can be mounted. Now suppose we have to machine a workpiece of any odd shape. So we'll mount this workpiece with the help of nut and bolt mechanism to the slots. And likewise, the workpiece can be held firmly onto a faceplate and can be machined. Now we'll discuss about various operations on lathe machine. First, we'll discuss about turning, that is external turning. Turning is an operation of reducing the outer dia of workpiece. This is the outer dia. Outer dia will reduce by first starting the machine. As we can see, the workpiece is rotating. The tip of the tool is brought at the original point. Then we'll decide about the depth of cut. From the outer surface, we'll move the tool towards the central axis of lathe. Now this is the amount of depth of cut, and the feed direction is given along the length of the workpiece from outer to inner surface. Now as you can see, the diameter of the workpiece starts to reduce. Now as we can see, this is the reduced diameter. This is the original dia and this one is the reduced diameter. The difference between the original dia and the final dia gives the depth of cut. So for example, if we have taken 2 mm of depth of cut, so total dia reduced will be 4 mm. Next, we'll show facing operation. Facing operation is generally carried out to reduce total length of the workpiece. Now, as you can see, workpiece is gripped in a 3-jaw chuck, and when we give a positive drive, the workpiece rotates. So first, touch the tip of the tool on the face of the workpiece. So here, the movement of tool is towards the center of the workpiece, and the depth of cut is along the length. As you can see, the tool moves towards the central axis. So the direction of feed and of depth of cut is opposite to that of turning. So this is how the length of the workpiece is reduced. Now if we want to reduce further the length of the workpiece from this surface to the required one that is given at the back, then we have to supply the depth of cut equal to difference between the two lengths and feed to be taken towards the central axis of the workpiece. So this is how the length is reduced and a facing operation takes place. Next, we'll do a drilling operation. The tool, that is the drill bit, is mounted in tailstock and the workpiece in chuck. So this is a cylindrical drill of size equal to the size of hole to be drilled. The diameter of the hole is equal to diameter of a drill bit. So we'll start the machine and carry out the operation like this. As you can see, the bit will move. This is a hand feeding given to the drill bit, and by the continuous feeding operation, the drill bit is moved inside the workpiece. So the hole of diameter equal to that of a drill bit is obtained. The length of the drilled hole we can measure at a regular interval of time by depth gauge or vernier calipers. This is how the drilling is done. Take care so as to never touch the chips coming out of a drilling process. So initially we should drill by small diameter bit, and further we can enlarge by using bigger bit. Now if we want to produce inner hole, then we can replace this drill bit with a reamer and do the reaming operation, which will remove small amount of material and will produce the inner hole. Next, we'll perform the boring operation. The boring operation is a process of enlarging the internal diameter of already drilled hole to a bigger size. And this boring operation can also be called as the internal turning operation. So we'll be showing you how this operation is performed, and the diameter of the already drilled hole can be enlarged. The tool used is a boring tool, and as you can see, the cutting edge is tilted or protruding outside. So now you can see that the internal dia is getting enlarged. What is required to be done is we have to shift the tool from the original point of contact towards the outer direction. So this amount of shifting will be our required depth of cut. So as you can see, the inner diameter will be enlarged. Suppose we gave the depth of cut as 1 millimeter, so the internal diameter will be enlarged by 2 mm. This is how the boring tool is feed into the workpiece and is moved towards the outer direction. And now next we'll show the grooving operation. So this is the grooving tool and this is the grooving edge of the tool. In the grooving operation, the width of the tool is equal to the depth of cut given to the workpiece. So as you can see, the width of the tool here is 3 mm. So the depth of cut will also be 3 mm. And the direction of feed of the tool is towards the central axis. This is how the tool is fed towards the central axis so as to generate the groove. This is the groove generated and the width of the groove is 3 mm, which is equal to the width of the tool edge. Now if we want to increase the depth of the groove, then we can increase it by feeding the tool towards the central axis. This is how the groove is enlarged. To further increase the size of the groove, we have to move the tool laterally and feed it towards the central axis. This is how the tool is moved laterally and is fed towards the central axis so as to enlarge the groove. As you can see, the groove is enlarging due to the lateral movement of the tool. So this operation is called as the grooving operation. Next, we will do knurling operation. Knurling operation is done to obtain a proper and efficient gripping on the workpiece. So this is the workpiece which is to be knurled. Knurling operation is basically done on the smooth workpieces. The tool used is a knurling tool which has got the two rollers. As you can see, one is at the bottom and another one is at the top. These two rollers rotates with the workpiece and leaves an impression on the workpiece and produce spiral knurls across the cross face of the workpiece. These knurls produce diamond point granules on the workpiece for proper gripping. As you can see, as the tool rotates, so the rollers on coming in contact with the tool also rotates and leaves an impression on the job. Thus, the diamond point granules on the workpiece are produced. We can also move the tool laterally so as to extend these knurls on the workpiece. This is how the knurling process is done. So as you can see, this is the rough surface produced by the knurling process.